Okay gang, let's try 59. So they're setting the domain from 0 to 2 pi. Let's take the derivative. Okay, to find the critical numbers, you've got to set that equal to 0. There's two ways students solve this. One way is to move the sign to the other side, so you're going to find out where they're equal. The other way I've seen students do it is they will I'm trying to think, another way I've seen students try to solve this is like this. They'll divide the cosine out. Cos over cos is 1, sine over cos is tan. So they'll find it a little easier doing it in this form, figuring out where the tangent is 1. So that would be in quadrant 1 and 2. Because in quadrant 1 the sine and cosine are both positive, and in quadrant 3, I don't know what I just said, this is quadrant 3, and in quadrant 3 the sine and the cosine are both negative, so the double negative makes a positive 1. And then you know what sides this is, because of its tangent it's the opposite over the adjacent, so it's 1 over 1, this is a radical 2, 1 over 1, this is a radical 2. That means your reference angle is a 45 degrees. Alright, then that means that your standard angle, let me just write it as x this time. Okay, so the reference angle, theta prime in this case is pi over 4, but you have to go and get the standard angle. That means you have to start from standard position. So the first answer is pi over 4, because the reference angle and the standard angle are equivalent in quadrant 1. And then you have to find the one from quadrant 3. So you've passed pi by pi over 4, which means you've passed pi by pi over 4. So if you get an LCD here, you get 5 pi over 4. Okay, so those are the critical numbers. So this is part A. Alright, so now let's set up the number line. When you set up the number line, just remember you have to stay within this domain, okay? Alright, you're going to put your critical numbers on there. Pi over 4 and 5 pi over 4. I don't know if I need to say this, but in case I do, the sum or difference of continuous functions are continuous. Therefore, there are no domain restrictions with this function. There's no like vertical asymptotes or holes or anything like that. No gaps. There's no discontinuities. Alright, so now let's pick some values. So just because some people find degrees easier, I'll convert this into degrees. That's 45 degrees. And let's see, this is 360 minus 45, so this is 315. Okay, these are your critical numbers. Alright, so if I pick something like pi over 6, that's 30 degrees. That would fall in between here and this critical number. So let's write down the derivative over here. So f prime of x is equal to cosine x minus sine of x. So again, you just want to know whether things are positive or negative. I'm plugging in pi over 6. And you guys know by now that I love my triangles. Alright, so pi over 6 is 30 degrees. That's always across root 1. 60 degrees across radical 3. 90 is the 2. Alright. So cosine of pi over 6 is the adjacent over the hypotenuse. Sine of pi over 6 is the opposite over the hypotenuse. Alright, so we just want to figure out whether it's positive or negative. You should be able to see from this spot that it's going to be positive, right? Because this number is higher. This number is higher than this. This is going to end up being positive. Alright, so that means this is positive here. That means the function's going up there. Alright, let's pick something easy in here. Let's go with, well, let me not put a mark there. Let's go with pi. Let's go with 180 degrees. That falls in between here and here. Alright, gang, so let's go back to using the derivative for that. So f prime of pi. So cosine of pi minus sine of pi. Now this is a quadrantal angle, so when I'm doing this in my head, I'm actually on the unit circle. I'm over here on the unit circle. So cosine of pi is -1, that's the first value. Sine of pi is 0, that's the sine is the second value. The output of sine is the second value. This is -1. So all that we really care about is that this is negative, right? So in here is negative. Remember, what's true for one spot is true for all spots in that segment. So if one spot's negative, they're all negative in that segment. Okay, gang, so now we're over here. This is 45 degrees away, so we have to want to get 30 degrees away. So pi over 6, 11 pi over 6. Okay, I'm going to go with 330 or 11 pi over 6. Okay, you guys sort of probably know my style by now. I'm going to draw that. That's going to rotate around. This is in standard position. This is your 11 pi over 6, which gives you a reference angle of pi over 6. Across from 30 is always the 1. Across from 60 is always the radical 3. And across from the 90 is the 2. Okay. Now, when you use, so the standard angle is 11 pi over 6. When you use the reference angle, that's not a negative. Did I write a negative there? They're always positive, the reference angles. Just remember, when you use the reference angle, it's always the reference angle plus the correct plus or minus of the quadrant. So, for instance, in quadrant 4, the cosine is positive, the sine is negative. Alright, so cosine of 11 pi over 6 would be the sign change. Cosine's positive in this quadrant. And then, so it's positive, the reference angle. The sign is negative of the reference angle. I'm just writing it out because I want to make sure you're registering that. So when you use the reference angle, you have to know what the sign is of the quadrant. So it's the sign of the quadrant and the reference angle together. The sign in the quadrant and the reference angle. Alright, so now this is going to be positive. Cosine of pi over 6 is radical 3 over 2. You have a double negative, which makes a positive. Sine of pi over 6 is 1/2, and you can see that this is positives. Okay, so this is positives over here. This is going up. Alright, so I finished part B. I just want to write it out nice, okay? So at this point, we just write it out nice. Okay, so part B. So remember, the behavior of the derivative is telling you what the function is doing. So say the function is going up on this segment, the function is going down on this segment, right? The derivative is telling you something about the original function. So notice here I'm writing the function, not the derivative. So I can say, looking at what the derivative is doing, I can say the function is increasing on the domain from 0 to pi over 4. And 5 pi over 4 to 2 pi. Okay, union. All right, f of x is decreasing from pi over 4 to 5 pi over 4. All right, so that's it for part B. Just telling, just stating that the function is going up on these domains and down on this domain. All right, then part C is your relative extrema. So you guys know how to do this, right? A maximum is when the derivative is positive, you hit a critical number, and then the derivative is negative. A minimum is the derivative is negative, you hit a critical number, then the derivative is positive. So it's that combination of derivatives around the critical number. Alright, so let's take a look. Let me get a pretty color here. So we go to the critical number, we look left and right of the critical number. So here's my critical number. On the left side it goes up, on the right side it goes down. So that means that this is a max. Alright, so we have a relative max at pi over 4. Now again, you do not want to plug pi over 4 into the derivative. If you do, it will equal to 0 because that's how we got that it was a critical number. What you want to do is plug this into the original function. Wow, I'm already over 11 and a half minutes. If this cuts off, I'll have to just pick it up in the next, I'll pick it up in another clip. All right, so just make sure, like, you're looking for an xy, meaning the original function. The original function. So the original function, again, is f of x equals to sine x plus cosine x. So you want to plug pi over 4 into this. All right, now that's a different triangle than the one I've been drawing a lot of. That's your 45, 45, 90. And that's your 1, 1 radical 2. That's an isosceles, that one. All right, so sine of pi over 4, 45 degrees is 1 over radical 2. Opposite over hypotenuse. Cosine of pi over 4 is adjacent over hypotenuse, 1 over radical 2. So that's going to be 2 over radical 2. Some of you will rationalize this, so you'll multiply it down like this, and you'll get 2 radical 2 over 2, or simply radical 2. Right, some of you, instead of writing it like this, you won't write it like that. You'll say this is radical 2 over 2 plus radical 2 over 2, which is 2 radical 2 over 2, which is radical 2. Okay, some of you will just go like that. All right, either way, that is the maximum height. All right, let's now do the other one. Hopefully this will hang in for me. All right, so we go into the other critical number. Now it's right here. We look to the left. To the left side, it's negative, so it's coming down on the left. On the right side, it's positive, so it's going up. If it goes down and then goes up, we know that that's a minimum. So at 5 pi over 4, you have a minimum. Let's do that one now. So we have a relative minimum, 5 pi over 4. Remember, we're going for xy. Do not plug this into the derivative. If you plug it into the derivative, it's going to be 0 because this is a critical number. You want to plug it into the original function like we did here. So this again is the original function. So now I'm going to do f of 5 pi over 4. So that's going to be sine of 5 pi over 4 plus cosine 5 pi over 4. Okay, now I'm going to make my lovely little diagram. 5 pi over 4 is here. So the standard angle is 5 pi over 4. The reference angle is pi over 4. The plus or minuses are the cosine in this quadrant is negative, the sine in this quadrant is negative. All right, so when you swap it, you have to use the correct plus or minus with the reference angle. So the sine is negative when I use the pi over 4. The cosine is negative when I use the pi over 4. So I'm converting it to a different angle, and because I'm doing that, I have to use the negative, the correct signs here. All right, now I know what the pi over 4, because we just did the triangle over here. So sine of pi over 4 is 1 over radical 2. Cosine of pi over 4 is negative 1 over radical 2. This is negative 2 over radical 2. And again, when you rationalize it, you're going to end up with negative 2 radical 2 over 2. That reduces, and you get negative radical 2. I know I did that a little fast. I'm just sort of worried about this movie quitting on me. So that's part C. There's your relative min right there. And there's your relative max right here. Okay? So those are the two answers. Alright, gang. This was a lovely problem. I hope that helped. I hope you got it. I'll catch you. Bye-bye.